Hi, I'm going to solve quiz 2 for week 7 of physics 2 that says like this. Transversal pulses travel with a speed of 200 meters per second along a taut copper wire whose diameter is 1.5 millimeters. What is the tension in the wire with a density of the copper of 8.92 grams times centimeter cube? And the second part says like this. Transverse wave travel with a speed of 20 meters over second in a string under a tension of 6 newtons. What tension is required for a wave speed of 30 meters over second in the same string? For solving this problem, in the first part, we will have that the velocity is equal to force over the linear density. Using this equation, we will have to obtain the tension, that is the force. So here we can get out the force of the equation and obtain that the velocity squared times the linear density is equal to the force, that is the tension. We also know that the linear density is equal to the density times the amplitude. So, for calculating the force, we will obtain that the density times the amplitude, that is the linear density, times the velocity squared, is equal to the tension. And these at the same time, we know that the amplitude is equal to pi, the radius square, and times the velocity square. This is this. Once we have this equation, we can substitute our values here. The force, that is the tension, will be equal to the density of the copper, that it's given in grams over centimeter cube, but here I'm writing it in kilograms over meter cube, so that's why we converted. The period was here, so I translated over here. This times pi times the radius square, but we know the diameter is 1.5 times 10 elevated minus 3. And for obtaining the radius, we divide it into 2. And this is square. Times our velocity square. And our velocity square will be equal to 200 meters over second. This is given by the problem. Once we have this equation, by solving it, we will obtain that the force, so the tension, it's equal to 630.5 newtons. This is the first part. For the second part, I'm gonna write it here. We are asked to obtain the force, the tension but of the second part. So we know that velocity 1, it's equal to our first one over our linear density. And we also know that the velocity 2, it's equal to the force 2 over the linear density. We are asked to obtain the tension in the second part when it returns. So, as this is given, we know that the linear density will be the same in both sides. So we can say that the linear density will be equal to the force 1 over the velocity 1 squared. This equation is obtained from this part, but at the same time, the linear density will be equal to this part. So, will be equal to the force 2 over the velocity 2 squared. Now, we are asked to obtain this one. We have this one. We have this one. We have this one, we have this one, and we have this one. Okay? For obtaining this one, we only have to, well, we won't really need this one, okay? We only have to use the three values. So the first two will be equal to the velocity 2 squared, this one goes up, times this one, okay? And this will be equal to 30, that is this one that is given, times 20, that is this one that is given, this square, times 6, that is our for our first tension here. And this will be equal to 13.5 newtons, and this is the tension of the string when it returns.